some of the functions are a little bit differently. We've already been introduced to functions. So you ought to be able to do this warm-up without any instruction. So function or not, determine whether each of the following is a function or not. Write function or not a function and explain why or why not. So everybody quietly take a look at number 1. You can just put it in the margin. Do you think number 1 is a function?
Yes.
Okay, Ryan, why do you think yes?
I think it's yes because the 1x does not have 2 y's.
Right. Each input is paired with exactly 1 output. So I would say yes, this is a function. Excellent. Okay, number 2. Roland.
It's not a function, and that wasn't a function.
Put your hands up.
I'll tell you why my hand was up. I think I left my pencil in Miss Pearl's room, so.
Can somebody help Roland out?
I can go to Miss Pearl's room and get it.
No. All right, we're good.
Awesome.
We're covered. All right, so no, this is not a function because the input here at 2 has 2 outputs. There's an output of 1, there's an output of 2. It fails the vertical line test, doesn't it?
Yes.
Okay. So far, we remember? Okay, take a look at number 3. Take a look at number 3.
Actually, it looks like -1's paired with like maybe 5 or 6, 5 point like something, or when like the arrow isn't directly on. I mean, it's a decimal or.
It should be on.
Okay.
Okay, so we'll say no, and we'll say because -1 is paired with, we'll call it 5. It's paired with 2 numbers, -1 and 5.
Is number 2 an equation? I mean, number 4?
Number 4.
What are we supposed to do with that?
Okay, here's my ordered pair, x comma y. It's going to represent the student's name versus the colors in the shirt color.
That is definitely a function.
That's a function. That's a function.
Skip.
I think.
Okay, so the majority says yes. Can anybody defend why no could be a possibility? Okay.
Because there's 2 boys, maybe.
There are 2 boys, but we're pairing the name with the color. What do you think, Matt?
If you are like maybe representing shirt as a 1 value and no shirt as a 0 value.
They all have shirts on.
They all.
Exactly. Which makes it not a function.
No, I know why it is.
Okay, Kyle, what do you think?
Well, because if you want to set it up in a table, you could have Vincent, then whatever. I can't read that. Kara, and then Roman under that. And then on the other side, you have the color. Oh, and then you have the color of the shirts lined up with those, and none of them repeat.
Okay, so we have green,
Because each name is only paired with 1 color.
red,
And but the only reason it wouldn't is
white,
What color?
Then all the names are all
yellow.
different.
Oh wait,
Okay.
I have 3 shirts.
Oh, Miss
No, that's a trick question.
Okay, that would be the only reason. Isn't Kara's shirt red and white?
Technically, yes.
Do you see
That's a
the
backpack.
do you see the collar?
What if it's one of those
That's
color
part
That's
of
a bunch of baloney.
That's the baloney.
Okay.
That is blogging.
That's ham.
All right. I'm just saying. I'm
Blogging
just
it.
saying. I could see how you could defend yes, if you didn't think about the collar.
Blogging it.
But her shirt is red and white. So you could also defend no in that possibility.
Collar should only be
All right,
It's not a color.
Matt.
That was tyranny. I think that was biased.
Okay.
White, scientists have proved that white is not a color, so there we go.
White is not a color.
Oh
White is not a color.
White, black, and pink are not colors.
It's the absence of
White.
color. All right.
So that's a win. That's a win.
All right. On the notes I passed out, this whole top part is review. There's a incomplete sentence right here. Sorry about that. I need to correct that. A relation pairs quantities, usually in our case, numbers, that are, here we go. Don't you like it when you define a word with a word?
No.
Related to each other by a rule. And we're going to work on the rules some today. relationship existing between two variables. But if each item from one set, what do we call it?
The
Domain. What else could we call it?
X.
The X, or the input, matches up with exactly one value from the other set. What do we call it?
The range.
The range, or output. Then it's a special relation, and what's it called?
A function.
A function.
A function. A function.
Okay. I want you to think about all the ways we've defined domain, and think about all the ways we've defined range, and list them under domain and range. Go ahead. You're defining domain and range in terms of all the ways we've used to define domain and range.
This with like words to define it, or words that we have used.
Or some we've used.
Oh.
Oh, I saw that. No, okay.
I can think of two.
No, we have to repeat one.
Okay, did anybody say X values?
I said X coordinate.
Woo, okay, good, good, good. Anybody say input?
I said
Anybody say independent variable?
I did.
Okay. Silly.
What church?
Okay.
Yeah, I just
Hey guys, could you stop?
I know, but
Domain is to X values as range is to Y values. Domain is to input as range is to output. Domain is to independent variable as range is to dependent variable. Very good. Okay, now the next section, we've already talked about how to determine if a mapping and a table is a function. But today we're going to add the rule part to it. Okay, number one, is this relation a function? What do you guys think? Yes, it is. Now let's see if we can come up with a rule. And for our rules, we're going to let X represent the input and Y represent the output, just for some continuity. X is your independent, Y is your dependent. X would represent domain, Y would represent range. Okay, Matt, did you know how this is related? What do you think?
I said f of x is equal to x squared.
Very good. I like the f of x too, but I had already called it y. So
Okay.
I'll just say y equals x squared. Yes, you square your input to get your output. Excellent.
Very good, Matt.
Thank you, Ryan. I'm glad I have your support.
Okay, number two. Do you think example 2 is a function?
No.
No. We don't think it is, because it's not. Number 2 is not a function. But we can still define it. We can still write a single rule to represent this. What do you think's going on? All right, Sabrina?
It's y is equal to the square root of x.
Very good. Now, because I want it to show the positive, there should be a negative right here, guys. The arrow went over the top of it. Because I want it to show the positive and negative here, I have to put the plus or minus here. Or I could write it this way: x equals y squared.
I never thought about that, actually.
That works. So we could write this one either way. Because it's not a function, we can go either way. All right, is number 3 a function?
Well, let's check it out.
No.
Yes.
No, it's not.
No,
Yes, it is.
No, it's not. There's two
Yes, it
things
is.
go to 8.
Yes, it is.
Okay, but 2 is only paired with 8. Each input only has one output. So it's a yes.
That's
How
embarrassing.
much support?
Okay.
Almost as embarrassing as my mom.
Don't actually.
My child told me I embarrassed her this morning too.
That's not very nice.
All I thought was, just wait until she's here. All right.
Be a senior when
She's in 6th grade, right?
Yes, y'all, you'll enjoy that. It's okay.
My brother's gonna be.
All right. Now, this mapping can only be represented by a piecewise function. It is a function, but there's not one rule that will work that will pair each one of these. So I'm going to split it up into 2 rules. I'm going to have one rule for the x values that are less than or equal to 2, and a different rule for the x values that are greater than or equal to 4. Let's try that again. 3. All right, so look at 1 and 2. Can anyone come up with a rule for 1 and 2?
You should find out.
Oh, this is fun. Very good. Times 2 plus 4.
I was honestly about to say that.
You didn't even give me.
Swear to goodness.
All right. I'll make everybody stay quiet for a minute because some of you are going to get this quicker than others. Look at how 3 is paired with 5 and 4 is with 8. Can you come up with a rule?
Times.
Shh, don't say it out loud. Let everybody have a chance. Okay, some people are really good at seeing patterns.
I'm not seeing it.
Okay, Sabrina, what do you think?
It's 3x minus 4.
It sure is.
dumb.
Times 3 minus 4.
That was dumb. You just gotta look at it.
You just gotta look at it.
Yeah, you do.
That's what I was gonna
All right. Now, we could have used found the slope and then point slope, and it would have worked too because I just gave you 2 points. Number 4. Is it a function?
Yes. No.
Oh, go with your first instinct.
Yes.
Yes.
If they don't repeat, then they're obviously.
Okay. If you're trying to take the shortcut, you have to see, do the x's repeat?
Right.
It's okay for the y's. I think that's what's tricking you up, right?
That's what's true.
All right. Each x is paired with only one y. That's the important part. Now, this is for 5 bonus points. If you can write one rule, can't be piecewise, just one rule that represents this table of values. Here's your hint. You need to put an absolute value in your rule.
I was actually thinking about that on number.
I don't remember that.
I forgot that.
Okay, nobody's ever taught you this. That's why it's for bonus.
Sweet goodness gracious. This is a scam.
I've had one person get it.
What's his name?
It's where
And or her?
the
Not
distance
and,
from
that'd be
0
weird.
on a line.
It makes everything positive. But you're right. That's why. It is the distance between 0 and a point on the number line.
This is dumb. I don't even
I'm upset.
We have a powder. We have powder.
That's Evan.
powder?
Yes, Evan is powder.
Yeah, I don't get it. I'm not gonna try if I lose.
I'm upset. I'm like,
See, he's a crier.
yeah.
I'm a powder.
I'm confused.
I'm a litigator.
You're a litigator.
Did you see this?
Did you know that he's on Dancing with the Stars?
That's why
He got a 4! He got a 4 and 5!
You got a 14.
That's
That's terrible.
Yeah, it was really bad. Bill Nye, the science guy.
Hey, hey.
I thought he was dead. I thought he was dead. I had a mom
Anyone?
Sorry, give me.
Roll it. Switch your phone away.
Yes, ma'am.
Dang.
Check my L's.
Evan, don't hit people with flying objects.
Or pencils.
Okay.
Anyone?
Can you tell me what natural number is? Yeah.
What absolute value is? Okay. Very absolute value is the distance that a number is from 0. So let's take a time out real quick and talk about what absolute value does. if I gave you this, the absolute value of negative 2, well, how far away from 0 is negative 2 on the number line? 2.
Got you.
What is the absolute value of 2? Well, how far away is 2 from 0? 2. Absolute value is a distance. It makes everything positive. Okay, so this is it.
Oh, I think I
It's negative 2x.
Y equals negative
Negative?
absolute value of x minus 5
I had that.
plus 6.
Shut up.
Ryan, you're such a liar.
Okay, let's test. If I plug in 1, I get negative 4 in the absolute values. What's the absolute value of negative 4? 4. The opposite of that is negative 4. Negative 4 plus 6 is 2. Checks. Plug in 3. Gives me negative 2. Absolute value of 2. Opposite, negative 2 plus 6 is 4. Checks. Plug in 5. 0 plus 6 is 6. Checks. 7. 7 minus 5 is 2. Absolute value is 2. Opposite of that is negative 2 plus 6 is 4. Checks.
Can we do another bonus one?
One equation that represents the entire function. Okay, now, number 5 is also a bonus problem, but this time it's only worth 2 points because we've already done one with absolute value in it. There's a hint. Okay,
I would take 2 bonus points any day
Yeah.
of the month.
What about any day of the year?
last period, Trevor Crispin got this one correct.
She's the only one.
He was the first one. I only gave it to one person last period.
Oh, we can use everybody if we get it.
If you write it down without looking on somebody else's paper that has just gotten it right.
Okay.
It's an absolute value one.
Yes.
Awesome. Hey, it's a question, Ryan.
Wait, so it is an absolute.
Yes.
Try to be so sneaky, Ryan.
It does have absolute value in it, folks.
I'm putting it down. I'm pouting. You give it. Ryan, try not to cry.
I don't need that.
You're crying. You're crying.
Oh! No.
Give us a little bit more time, please.
At least you gave up with a positive attitude.
I always have a positive attitude. I'm a positive person.
I would agree with that statement.
No, he's not.
Kevin, I felt you doing it like 8 times.
I can't figure it out.
Ooh.
I'm gonna take a moment.
Okay, who wants me to come look at theirs?
Nick.
You have to be.
Take a moment.
That might be right.
I think it is.
I think you're wrong.
Say he's wrong.
I'm wrong.
There's one
Well, Ryan, I think you're
that's
wrong.
not right.
Ryan, I think you're wrong. Ryan, I think you're wrong.
Ah!
Yeah, Ryan, you're wrong.
Everyone else.
Ryan, you're wrong.
No.
Ryan, this only.
No, it's that last year.
I don't know how you write it.
He's out.
Yeah, that's gotta be a piece question. There's no-
She
there's
wrote
no
something
way.
down.
There's no way I got that correct. Mine, that?
Feeling the fun?
I don't even think I got mine anywhere near.
I don't have Trevor's paper, so I don't have
No, she. Yeah.
Oh, okay.
Is that wrong?
Oh, mine?
Oh, I see.
And you didn't even make contact. You did?
Way to ruin the surprise.
No.
No. Right now it's my
I gave up.
Or you saw my paper.
Anybody else?
Okay, I'm serious.
Did anybody get it?
You didn't feel it when I did it. I feel it.
Did anybody get it?
Yes,
Zap did.
Sabrina did.
Ah. What was the answer?
Okay, but rolling yours is really 2 rules because of the plus or minus. But I'm going to give you 1 bonus point.
Okay.
Nice, Roland.
Yeah.
All right, so
Nice,
x
Roland.
equals the absolute value of y over 2. Or absolute value of 1/2 y. Or, how'd you write it? The absolute value of y divided by 2.
Yeah.
Yeah,
Oh, I had negative.
you had a negative out in front.
Yeah. Okay.
Otherwise yours would have been
Right.
right.
Yeah, that's
Yep.
So it's one point.
It's a yes or a no?
No.
It is a no.
It is a no.
That's a
You're
no.
correct.
Yeah.
Okay, now here's the new part, other than the writing the rule. Here's the new part for us that we didn't do in the first unit of this year. Okay, and it goes like this. We test algebraically to see if a relation is a function. Okay, first thing we're going to solve for y. That's our first thing. We're going to solve for the dependent variable. And then we're going to test by plugging in values of x to see if every x value leads to only one y value. And I want you to test a positive number, 0, and a negative number, if possible. Sometimes it's not possible, but. All right, so number 6. First thing we're going to do is solve for y. So this is a literal equation. We want to make it y equals. So what needs to move first?
X.
The x. So we move it to the other side by adding x. Now, last period they let me know that they had never really, some of my students had not worked with problems like this. How do you solve a square? What undoes a square? A square root. And when you take square root to solve an equation, you always do the positive and the negative. Because positive 4 squared is 16 and negative 4 squared is 16. Last period, some of my students told me they hadn't done this part before, the plus or minus.
Right.
Okay? So here, when we're taking the square root of this side, the square and the square root cancel and we're just left with y. But here we're taking the square root, and because there wasn't one before, we're doing the positive and the negative. Positive and the negative. So y equals plus or minus the square root of x plus 1. So I'm going to pick a number for x that makes sense to me. 3 makes sense, because 3 plus 1 is 4, and I know the square root of 4. So I pick a number that makes sense to use, 3. If I plug in 3, do you see I get out positive and negative square root of 4? What's square root of 4? 2. So when I plug in 3, I get out 2, and I also get out negative 2. 1 input, 2 outputs. Is it a function? No. 1 input can only have 1 output. We have 1 input and 2 outputs. So, is this first one a function? No, it is not. 1 input paired with 2 outputs, not a function. Okay, number 7. To solve for y, all we have to do is move the x squared over, isn't it? And when I do, it becomes negative. So I can just write 1 minus x squared. There we go. Now, let's choose a number that makes sense to me. What's a number that makes sense to y'all to use? What numbers can I square? Any numbers, can't I? You want to square 2? Okay. When I plug in 2, I get out negative 3. 1 input, 1 output. So far, so good. Let's test 0. If I plug in 0, what do I get out? 1. Ooh, I'm still doing well. Let's test a negative number. Negative 1 squared is 1. 1 minus 1 is 0. 1 input, 1 output. 1 input, 1 output. 1 input, 1 output. Is it a function?
Yeah.
Yes.
Well, now you just confessed me.
Now, if I graphed this first one, it would look like this. A parabola that opens that way. Does that pass the vertical line test? No. If I graphed this second one, it would look like that. Does that pass the vertical line test?
Yes.
Yes, it does. So we know how to do it graphically, but you don't know what those graphs look like. This is how we do it algebraically. So let's come down here and look at these examples. Example 1, y equals x plus 3. Please tell me we do not have to test this because you know exactly what this is.
I know exactly what that is.
What is it?
Linear function.
It is a linear function. So yes, it is a function. Kudos. Thank you.
Good job, Ryan. Good job.
Okay, we know this is a line. We know it's a line that passes through 3. It's a diagonal line. Boom, it passes the vertical line test. We could tell algebraically. We could test numbers and see that they work, but we don't have to because we know what it is. All right, f of x, doesn't that mean the same thing as y?
Pretty much.
Yeah. So this one's already solved for y. We're good. So let's test some numbers. Now, let's test like 14. Okay, 2. That's fine.
Yes, thank you.
Let's test 2. If we plug in 2, we get the square root of 4, which is
2.
2.
2 and 2, baby.
Let's try 0. What is 0 plus 2? 2. Does anybody in here know the exact simplified answer for the square root of 2?
1.
It's just the square root of 2.
I
It
was about to
doesn't.
say that. Ryan didn't work something out like it.
It doesn't simplify.
I don't know, I was guessing.
You know,
Well, you
one
can
times
guess
one is
math
two
because
now.
you're
All right.
going to get it wrong.
Negative 1. Negative 1. 1. Okay, 1 input, 1 output. 1 input, 1 output. 1 input, 1 output. Function? Yes. Okay, you guys don't know this yet, but you will soon. This function looks like, I call it the eyebrow. Looks like that. Okay, the next one. It's already solved for y. See, g of x equals. And let's just test them. What numbers would you like to use?
2.
2. So if we plug in 2, we get out 2/5. Okay. What about 0? If I plug in 0, what do I get out? 2/3. Let's plug in negative 4. What do I get out? Negative 2.
Wouldn't it be a negative 2 for x?
Oh, negative 4. That's what
2, 4, we want to have.
I was just randomly picking x's.
So yeah, it's a function.
Yes, this is. Now, is there a value that x cannot be, though? Is there a restriction on the domain for this problem?
There is.
There is. I've asked you, right?
Correct.
Okay. What is the restriction on the domain? What can x never be?
Can it be y?
Give me a decimal.
0.1.
Nope. We're going to sit here until somebody accurately answers this. Nope, there's one number x cannot be. What is it?
Infinity.
0.
Did I get it right?
2.
You didn't touch me, man.
Infinity and
My shoulder.
That's not right.
Look, my other arm.
1.
3.
One. I already told you.
5.
One
What do you got? No,
9, 10, 11, 10.
7.
Pi.
12.
Okay, what number cannot divide by?
0.
Zero.
Negative 3.
Thank you. X, the restriction on the domain is x cannot equal negative 3.
I said negative 3. No, you didn't.
Yeah, he did.
Oh, you did?
I actually did, bro.
He did.
Bro.
I didn't hear you, I'm sorry.
Bro.
All right,
I actually do.
okay.
I can't see.
So what that means is if I graph this function, and we'll eventually do this, if I graphed it, it would look something like this.
I look fine.
And you see that there is an asymptote,
Oh, that's silly.
a line right here that the graph approaches. It gets closer and closer and closer to it, but it never touches it. And it doesn't cross that vertical asymptote. Okay, this one, a of r equals pi r squared. How many of you recognize that as the formula for area of a circle with
I
respect to
did,
the radius?
actually.
Good. So if I plug in 1, I get out pi. If I plug in 2, I get out 4 pi. If I plug in 10, I get out 100 pi. Okay, why didn't I test 0?
0 would be 0.
If it's 0, is there a circle? Thank you. So a radius of a circle has to be greater than 0 or the circle doesn't exist. So I only tested positive numbers there. Okay, is this a function?
Yeah.
Yes. And if I graph this,
It looked funny.
no, it's actually not that funny. It's just the right side of a parabola.
That's surprising. I thought it was
That's all it is. Okay, this one is interesting. We got to solve for y. It's our first one we actually had to solve for. So we'll subtract the x squared. So we get 9 minus x squared. And then to undo the square, we take a square root of both sides. And when we take a square root, we always get the positive and the negative when you take a square root. Okay. So let's pick a number for x. Let's pick 0. Okay, 5. I'm good with 5. Good choice. Who said 5?
That was me.
Nice job, Evan.
Dang,
All right.
so positive.
Oh, actually, square root of 5 would be better. We can't do 5.
Oh.
You took my letter.
Sorry, I took it away. Let's do 0. It was square root of 5 I was thinking of. Sorry. All right, if we plug in 0, what is 0 squared?
0.
So 9 minus 0 is
0.
9. And the square root of 9 is 3. But there's a plus and a minus. Do you see 0 is paired with positive and negative 3?
Which makes it not a function.
Not a function. Okay, now the graph of this one is a nice conic that we will study. It's called a circle.
Oh.
What?
That's a terrible circle, but it's a circle with a radius of 3. It's a circle with a radius of 3.
That is weird.
Okay?
That's very different.
All right. The back side of this worksheet is for homework, but you have a good amount of class time remaining to work on it. Please note that on 5 through 8, if you determine that it is a function, please write a rule. On 5 through 8, if you determine the relation to be a function, please give me a rule. Okay, your homework is to do all the circle problems.
Oh.
Everything except for
Not like a